If you notice, we're going to do 2 days of this. It might take us more, but we're doing day 1 of 3.6 with factoring by grouping. And the whole premise of this is sort of like, I might think of this as a different problem of x times y plus 7y, where, I don't know if this is obvious, but I'm trying to think of y is equal to 2x plus 1. Well, if we did the problem the way I've talked about so far, you could factor out a y, and the remaining pieces would be x and 7. And you can double check that this is right, because I can distribute y into the problem. I'm back to the original. So my whole conjecture then would be, as long as you have the same quantity, you can write it once in front, because again, I'm letting y be representative of this 2x plus 1. And then the other piece is going to be the x and the 7. And this is just an introductory skill to get you to understand. And let me highlight, the whole premise is, as long as this and this are the same, then we can write it once in front, x minus 2, and then the other set of parentheses would be that 5x minus 4. And we could work through a lot of examples as to why these are equivalent, or you can just believe me. Now the next one, again, there's a quick way of noticing that you have the same parentheses, so you can write it in front, and then you have x plus 5, and then plus, from this sign, x plus 1. So what your final answer would be then is I would ask you to rewrite this as 2x plus 6. And let's just leave that alone for right now. I know you could actually greatest common factor of 2 out of that. But where it gets a little bit trickier, let me just go back to that blue color, is what do you do when you have this minus in the problem? You still have the x plus 4, which is identical, but then what you have is 2x plus 8, and you have to distribute that minus to each piece, so minus x plus 2. So your final answer on this one, yes, it's x plus 4 still, 2x minus 1x is x, and 8 plus 2 is 10. There you go. So moving on to the next one, this is going to prepare you for a different way of doing this, but they just want you to test the equivalency with certain values. So I'm going to leave a little bit of space. So the correct factored form would be the x plus 3 in front, and then you're left with x minus 4 plus 5, which you could then reduce. Negative 4 plus 5 would be x plus 1. So the premise of testing equivalency is plug in 2 in for all of these x's and see what happens. And also plug in 2 for these x's down here. So if I did the top one, 2 plus 3 is 5. 2 minus 4 is negative 2. 2 plus 3 is 5. So what you have is negative 10 plus 25, or 15. Well, if I did the same thing down here, 2 plus 3 is 5, and 2 plus 1 is 3. 5 times 3 is 15. So yeah, I got the same answer no matter what. So this next one is just trying to get you to recognize the premise that you can factor by grouping. So notice that there are 4 terms right here. Count them with me, 1, 2, 3, 4. So we split it up with the first 2 terms, so we group. That's where we get the name of it, grouping the 4 terms. This is called the associative property. That word, I'm getting lazy. And then the next step, what they did is they greatest common factored out of those groupings. That's also the undoing the distributive property, this word right here. And then from this, we have the common factor that we can pull in front, and then we can group things together, 2x squared plus 5, and I would again call that the distributive property. The answer key might be a little different, but I would call that the distributive property. So it's a problem that's already set up for you that makes it a little bit easier to work with. So let's practice a few of these. Notice that we have 4 terms. If we have 4 terms, we can group. So if I ask you for the greatest common factor, in the first 2 terms, that would just be x squared, and you're left with 3x plus 2. And double check my math. If I distribute that in, it should be equal to that other piece. My whole goal, if you've noticed, is I want 3x plus 2 again. So it makes sense to me that I need to factor out a negative because they're both negative. And then negative 9 times 3 is negative 27. Negative 9 times 2 is negative 18. So that was right. And then from here, I have the same thing in the parentheses, so I can write that once. And then where I get my other piece would be the x squared and the minus 9. Now here's the thing. You're not off the hook now because we also have a difference of squares there. So your final answer and best answer, remember x times x is x squared, 3 times 3 is 9, make 1 plus, make 1 minus, and you have the best answer. If you don't believe me, start distributing all this out and you'll get back to that original problem. So I'm going to do this next one very similarly. Group, that's all you have to do. The 4 terms, group them. Greatest common factor, 9x squared, and you're left with 2x plus 1. And again, my goal is to get the 2x plus 1 on the other one as well, so it makes sense to factor out a negative 1. These pieces are the same, so we can write it once. And then your other piece would be the remaining pieces, 9x squared minus 1. And again, we have a difference of squares. It's not always the case that we have a difference of squares. It's just been happening here and here. 3x times 3x is 9x squared, and 1 times negative 1 is negative 1. So that is your final answer. And as we move on to the next one, I hope you agree. Yeah, we have 4 terms. If we have 4 terms, we can group. So the greatest common factor there appears to be x cubed, left with x squared plus 4. Group the last 2. Greatest common factor there is 2. Again, you're left with x squared plus 4. And I like this example because some people get in the habit, but this is a sum. We don't have a method for doing the sum of squares, so we'll leave that alone. And x cubed plus 2, nothing is special there. So this is all you can do. And you can double check this is the right answer, because if you distribute it in, and this one would be easy to distribute and check your work. X squared times x cubed is x to the 5th. X squared times 2, 2x squared. 4 times x cubed, 4x cubed. And 4 times 2 is 8. So it'd be easy to check your work on that one. And then just one more for this. Greatest common factor there is 5x squared. You're left with x plus 2. Greatest common factor between these two would be 20. You're left with x plus 2. You write your like parentheses, just write it once, and then you're left with 5x squared plus 20. I didn't realize this until now. You actually do have a greatest common factor here, which we also had a greatest common factor to begin with. So the best answer would have had a 5 factored in front. So I apologize for doing it this way, because I suggested earlier in a previous video to do your greatest common factor first. But you can actually do your greatest common factor at the end as well. So we can also do this with a bunch of letters. I know this might give you some sort of anxiety. But what you can do is you can actually rewrite so that you see how the first 2 terms do not have anything common. Nothing is common with those first 2 terms. So you can actually rewrite it. And it doesn't matter which one you move around, but you could just use the commutative property. And I move the AB to be over. And maybe you could try a different setup, and you'll still get the same answer. So what you can do is group the first 2 together. It has the greatest common factor of x, left with x minus a. If you look at the next 2, the greatest common factor there is, well, maybe what I would actually do is make it a negative b. because I want to make sure that I have a negative x, a positive x, just like the same thing here. And double check if I distributed it in negative b times x is negative bx, and negative b times negative a is a positive ab. And the whole point of that is then they're exactly the same, x minus a, and then also x minus b. And that would be our best answer. And then there's just one more exercise to get you to think about that there's an error being made in this problem. And the way I would do this is actually just work it out. 2x cubed and 10x squared. Well, 2x squared, that was right. And double check that's right. 2x squared times x is 2x cubed. 2x squared times 5 is 10x squared. If we look at the next one, there is a 7 that's in common. But here is our issue, is the x, let me do this in red. This x plus 5 and x plus 3 are not the same. So at this point, we don't have a greatest common factor. That's not a common factor to pull in front. So we cannot do this problem that way. So in this instant, I would just say that there's really no way of simplifying beyond that point. Everything after that point would be incorrect. And I think you're ready for the homework now. Oops, it doesn't say homework on here, but that's what it is. The skills practice would be your homework.